All right, we all know how to graph linear functions, and more recently we talked about graphing quadratics, which end up being a parabola. But today we're going to take it one step further and talk about polynomial functions in general and their graphs. Okay, so a general polynomial might look like this, where f of x is equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 and all the way out to a sub 1 x to the 1 plus a sub 0. Okay, so this would be a generic or general polynomial function. So the first thing we're going to talk about here is the end behavior. Well, what do I mean by end behavior? End behavior is basically what this graph is going to do as x gets very, very, very large and as x gets very, very, very small. Okay, what are the ends of the graph going to look like? And this is totally dependent on two things here. And that is, it's dependent on a first of all, and it's dependent on n. So if n is odd, in other words, it's an odd degree polynomial, and a happens to be a positive number, then we can say that the graph falls to the left and rises to the right. Okay, so what do we mean by that? Well, basically, if you've got something like this, that means it's going to fall to the left, and it's going to do something and then rise to the right. It's going to look something like that. Now let's say that n is odd and a happens to be negative. Okay, in this case, you would rise to the left and fall to the right. So it might look like something like this, where it would be rising to the left, do something in the middle, and then fall to the right. Okay? So now what if we have a case where it's n is even and a is positive, all right? In that case, it rises to the left and rises to the right, and it would look something like this. It would come down, do something in the middle, and then go back up, okay? All right, then the last case would be, what if n is even and a is negative? Well, in this case, it falls to the left and falls to the right, so it might look something like this. Whereas it comes up, it does something in the middle, and then it falls back down. All right? So those are the four cases for end behavior. So now we'll talk about finding the zeros of a polynomial function. So these can be referred to by any of the following as either the roots, the solutions, or the x-intercepts. All right, so let's look at an example here and see what we can come up with. So let's say we've got f of x is equal to x cubed plus 3x squared minus x minus 3. All right, now we're going to start by factoring this. First of all, there's nothing common here, so I can't take anything out that way. But if I look at it in terms of grouping, I can see that I have something common in the first two terms, namely x squared, which leaves me with x plus 3. In the second two terms, I've got a minus 1 that's common, which also leaves me with x plus 3. And now I can factor this as being x plus 3 times x squared minus 1. And x squared minus 1 is simply the difference of squares. All right, so the solutions for this, or roots, or x-intercepts, are that x could equal minus 3, x could equal plus 1, or x could equal minus 1. So these are the zeros of this particular polynomial. Now there's another term here, and that is the multiplicity of the roots or solutions. Each of these solutions has a multiplicity of 1 since they only occur once. If there is a root that occurs more than once, for example a double root, then it would have a multiplicity of 2. This is important only when you're graphing, because if it has a multiplicity of an odd number, then the graph cuts through the x-axis at that point. If it has a multiplicity of an even number, then we know that the graph just touches the x-axis at that point. All right, next we have the intermediate value theorem. This is used to tell us the existence of real zeros, or in other words, x-intercepts. This is probably best explained if I were to show you an example. So let's say I've got an example here of f of x is equal to x cubed minus 2x minus 5. And I want to know whether or not this has a real zero between 2 and 3. So basically what you're going to do is you're going to plug in x equals 2 and then x equals 3 and see what you get for an answer. And all we're concerned about is whether it's a positive or a negative. So the first thing I'm going to do is calculate what the function is at x equals 2. And we've got 2 cubed minus 2 times 2 minus 5. And if I crank out the numbers here, I end up with 8 minus 4 minus 5. And that simply gives me minus 1. All right? Now I'm going to do the same thing for x equals 3 and see what I get. So I want f of 3. So that's 3 cubed minus 2 times 3 minus 5. And that would be 3 cubed, 3 times 3 is 9, times 3 is 27, minus 6, minus 5, and that comes out to be positive 16. So since this first value was negative and this second value is positive, then we know that between 2 and 3 this function does indeed cross the x-axis. All right, the last thing we're going to talk about is turning points. Now, turning points are where the graph changes direction from, in general, going up to going down, or from going down to going up, okay? You might think of these as something like max or min points. And basically, if a polynomial function has degree n, then the graph has at most n minus 1 turning points. So it's 1 less than the degree is the most number of turning points. Okay? So that's all I got for right now. We'll talk to you later. Thank you.